I wanted to start by taking a very brief look at the background to BIM and what is BIM and why is it important. So if we start with the very basics, BIM stands for Building Information Modeling, and the whole philosophy behind building information modeling is to provide a digital representation of physical and functional characteristics of a building or a facility, and for that shared knowledge resource to provide information that forms a reliable basis for decisions to be made throughout the life cycle of that asset. The history of BIM stretches back some little way. If we take a look at the timeline, you'll see that stretches all the way back to 2004. So it's not a recent innovation, but it's a very, very important one that's taken a little bit of time to gather momentum, but is becoming much bigger and more important as we go forward. As we see in the timeline, way back 2004 time, there was a study produced in the US that estimated that something like $15.8 billion is lost annually just purely in US capital facilities procurement and construction through poor quality of information exchange. And the whole philosophy about BIM is to figure out how to eradicate that wastage and how to optimize the processes over the full life cycle. As we know, historically, the construction industry has operated from 2D drawings, quite often produced in proprietary software packages. But now in 2015, there's no reason for that to continue to be the case. It's very much an opportunity to move forwards in a 3D world and have high quality, high granularity 3D models built for the buildings and infrastructure that we're constructing. The government's identified this potential saving many years ago, but what they've been seeking to do in terms of encouraging the supply chain to commit to progression is to set down not only the BIM standards, but to actually stipulate that BIM adoption will be mandatory for all construction projects greater than 5 million sterling. Now, that was the UK government that set that stipulation. By 2016, all their procurement construction projects greater than 5 million must be BIM compliant. Many other governments around the world have taken a similar approach of mandating compliance as a means of helping encourage the investment and evolution of the supply chain to implement BIM. That's clearly paying off because, again, if we look at the timeline, there was survey results produced very recently that showed that across 1,000 different UK construction companies that were spoken to, BIM adoption has increased from 13% 4 years ago up to 54% in 2014. So it's gone from a relatively small niche in the construction industry only 4 years ago to being absolutely mass market and widely available and indeed almost ubiquitous, because we're now beyond that 50% uptake level. Next year is obviously an important year in the evolution of BIM also, because that's when BIM compliance is mandatory for all the government projects, and that's 3D BIM. Now, if I give a tiny little bit of background about the different levels of BIM, there are 4 different levels of BIM compliance that can be achieved from level 0 to level 3. Level 0 in its simplest form essentially means no collaboration at all. It's continuing the use of 2D CAD drawings and either ad hoc sharing or sharing via paper. If we then move to the next evolutionary step, level 1 BIM, this would typically be moving into a 3D CAD world, but maybe not with the level of interoperability that we ideally want. And this is where many organizations are at the moment. But then once we move to level 2 BIM, that's where there's collaborative 3D models being worked on by numerous organizations inside the supply chain, all working with that single model. Then the final and most advanced level of BIM implementation is level 3, which is when we get to absolutely full collaboration across all disciplines with a single shared project model held in a centralized repository. Many organizations are striving for that, but there's widespread acknowledgement that it may actually be a little bit further in the future until we get to level 3 level of BIM compliance. And many people are predicting it might be nearer 2019 until we see large level of uptake. So that 2016 milestone that we see is really about the level 2 BIM compliance, and that's very much what people are striving for at the moment. The other thing I would like to point out on BIM is that whilst it was originally conceived for buildings, it's equally relevant and applicable for various other types of capital infrastructure projects, particularly in transport infrastructure. So for ports or airports or highways or railways or metros, the whole philosophy and concept of BIM is every bit as applicable as it is for buildings. If we take a look at why BIM is important, as I say, many of the public sector organizations and governments worldwide are seeking to push implementation of BIM as mandatory in order to ensure that they leverage their supply chain to get that 20% saving of whole life costs. And the very fact that large construction companies will not be eligible for tendering for government contracts unless they adopt BIM is very much uppermost in the minds of some of the leadership teams in the construction companies, that their compliance is absolutely essential in order to still be considered for these large-scale construction projects. The collaboration element is equally important. Having a common one truth digital model for each of the organizations involved in a project throughout its life cycle absolutely minimizes the risk of wasted work or defects in the design stage not being picked up until later stages of the life cycle. And this is especially important as we move forward. Then I'm quite often asked what I regard as the key benefits for implementing BIM. So I've endeavoured to pull a bunch of them together on this slide that steps through what many of the key advantages are in implementing BIM. If you take a look at a few of these, the accurate visual design and no shortcuts. Essentially, the BIM model is set, and there cannot be gaps in the model. Data gaps show up very obviously, and that's what we mean here by making sure that the design is complete in all details. Having the product components in catalogs and libraries absolutely optimizes the opportunity for reuse and simplification, which naturally leads to further savings. Information on materials and components available for operations and maintenance and facilities management is also key, because what we quite often see as projects transition from construction phase to in-life operation, that level of knowledge transfer from the builders to the operators maybe isn't as good as it could be. So again, optimizing that information exchange to make sure that components and stock levels are optimal right from the outset is extremely helpful. Obviously, accurate life cycle cost estimation is always important, but in capital projects often running to many hundreds of millions or billions of pounds, that can make a really big difference. Reducing the risk in life cycle fund management is also critical, because too often there are unnecessary risks introduced by a lack of careful consideration of the different perspectives at the design stage of a project. I won't step through each of the others in turn. I don't think time permits today, but as you'll see, there's quite a few different areas. And in terms of building business cases for investing in BIM, I've helped a couple of organisations develop their business case that flush out quite a few of these different areas and endeavour to model what the savings are associated with each of them, which obviously varies from project type to project type. Much is spoken about 3D modelling in terms of BIM, but a couple of other bits of terminology that you might come across. Some people refer to it as being 4-dimensional modelling, 4D modelling, and some even talk about 5D or 6D. If you hear it described in that context, the 3D is the traditional length, width, height dimensions, if you like, the X, Y, and Z dimensions. The 4th dimension is time. So we can see as a project progresses how the build will progress at the different stages, and that can be enormously helpful. So for example, in some transport infrastructure projects I've seen, modelling the time angle when you're remodelling a railway station that's still in use can help optimize passenger flows through the construction site and around the construction site. So that can be very important for certain types of projects. Obviously, cost modelling goes hand in hand with that. If we've got an accurate 3D model progressing over time for how a project is being built, how a construction project is being undertaken, then if we can see the costs evolving by each stage as well, then that can be enormously helpful. And then finally, the 6th dimension, the facilities management. It's back to what I touched on earlier about the information flow between the construction, the build phase of a project and the operate phase of a project. So then if we look at what some of the key implementation challenges are in a project such as this, collaboration is obviously key. That's where the key financial savings are that have been identified by the various research papers that have looked closely at this industry sector. Quite prominent amongst these is the known ineffectiveness and inefficiency of what's called handover handback at the moment. So what we see quite often in infrastructure projects is that the client organization maybe owns the initial high-level design phase through to feasibility and agreeing to proceed with construction. But then they'll maybe hand over the project to a construction partner to undertake the actual detailed design and build stages. But then having handed over to that construction company, there'll then either be a handback to the client for the operation or a handover from the construction company to a facilities management organization. And it's these handovers that quite often are where inefficiencies come in because of the poor quality of collaboration and information exchange. Then if we're moving into that more collaborative world, information security faces different challenges to the previous world where information is maybe locked up inside an organization. To keep the information secure, if it's very much stored inside an intranet inside a single company is a somewhat different challenge to keeping that information secure when it's maybe a shared information base, perhaps cloud-based. And it's perfectly feasible to keep the information every bit secure, but the detailed specifics of how that implementation of that security policy gets done changes somewhat as we look at that collaborative model. Then if we take a look at data volumes, there's a project that I'm working on at the moment that the 3D model and data set and imagery associated with it is 220 terabytes. So that's by no means unusual in this world for data volumes to be very, very large. And they're only going to go in one direction, which is upwards. So that, again, that's something that has to be taken into consideration at the outset of the project. And another thing to bear in mind is how we're going to staff up projects with suitably skilled people, because the BIM specialists that are around are quite scarce. And if you recall, the ramp up is sort of more than trebled over the last couple of years, which shows that demand for skilled resource is running quite a bit ahead of supply. So that might lead us to think about whether we want to invest in growing our own specialist skills inside our own organization, or whether we maybe want to partner with another recognized established specialist and draw on their skills perhaps. So it's just a few dimensions of the implementation challenge to think about. And that pretty much covers the introduction part that I wanted to step through today. So what I was going to do now is hand over to Sudarika, and he'll take us through a little bit more detail of what he's been doing with the BIM Exchange platform.
Okay, thanks a lot, Derek. So in this section, I will be elaborating on the BIM Exchange platform, its inner workings, and why and how we built, and what's the motive behind building a BIM Exchange. So as Derek explained, we understood the importance of BIM and why many construction companies nowadays are compelled to implement it, etc. When it comes to BIM, what is BIM Exchange? When it comes to BIM, it is a standard, and essentially it represents a data model that could represent different kind of data generated in a large construction project or an infrastructure project for that matter. Such a large project involves dozens of teams, could be located in a disparate geographical locations, and maybe performing entirely different set of tasks. For an example, probably an architecture team working on a particular infrastructure project, coming up with architectural designs of the site, and maybe they're generating 2D or 3D models with geometric data in it. And these designs predominantly contain structural information, so probably such as walls, roofs, floors, doors, and windows. On the other hand, maybe a mechanical team who is working on placing a boiler into a boiler room, maybe utilizing the room which is designed by the architecture team. And on the other hand, maybe the electrical team could be working on how the wiring and the electrical panels are placed, and also maybe the plumbing team is working on the pipelines and water management, aspects of it, etc. So the data produced by each team, performing all these things in a construction project, has to be shared among the teams effectively. One of the points mentioned by Derek is the collaboration. That is essentially complements this fact. So this has been the historical problem all along. While doing that, missing information led to many projects to introduce a lot of wastages on money and time, so on and so forth. Another major problem is once the project is completed and handed over to the project owner, the critical information of the project is not organized or else completely missing. And this caused many issues to maintain the project going forward after the construction is done. With the introduction of BIM, it actually aimed to address this problem and introduce a way to centralize and share information in a predefined data model. We're talking about industry foundation classes, also known as IFC, that is the basic building blocks of BIM. I will explain about the IFC standards in the next slides. By considering all these problems faced by the industry on centralizing BIM data, we at Mitra Innovation looked into the possibility of developing a platform that could be used by different teams involved in a large construction project for data consolidation. So this is the very inception of the BIM Exchange platform, as you see in the screen right now. So software designed for AEC industry today are conforming to BIM standards. They have the ability to generate BIM compatible IFC based data. On the other hand, there are these legacy applications that are not BIM compatible, but they have been in use for many years. And our objective of the BIM Exchange was to create a stage for all these applications, which are BIM compatible and non-BIM compatible applications to communicate with each other and on a central platform. So we built an API around this using BIM Server open source platform with additional set of features that could add a lot of value to a large infrastructure project. And we wanted to make sure we build a very sophisticated framework. Therefore, we used our partner company's WSO2's middleware platform. So as you can see in the image, there are many teams involved in a large construction project. There are architects, there are engineers, there are project managers, and there's the project owner. And BIM Exchange acts as a platform for all these stakeholders to work as one single team. BIM Exchange API is a very feature-rich API. It actually allows the applications to integrate and contribute to a BIM project. An IFC file is generated by a BIM-compatible application, could be checked into BIM Exchange via the API given for a given project. The BIM Exchange shall validate and check the validity of the IFC file checked into the BIM Exchange and execute necessary business rules. The API functions are also available to download an IFC file from the BIM Exchange. This could be merged between two different teams, like one architecture team is working on their design and they generate one IFC file, and the plumbing team is working on one IFC file. So they check in both this IFC file using the API, and those IFC files could be merged and come up with a consolidated model. This way, all these different applications used by the architecture team and the plumbing team could integrate together using the common API. BIM Exchange is also extendable. It could facilitate legacy applications to become a part of BIM Exchange. This is done by developing a custom legacy connector whenever you have a legacy application, and that could start to emit IFC-based data from a legacy data stream. Once the legacy application is connected to the BIM Exchange via the legacy connector, it could become as good as a modern-day BIM-enabled application. Something really cool about BIM Exchange platform is that it could actually extend to perform vendor-specific services by consuming them. So we have a way to configure several services inside the BIM Exchange using the configuration, and this built into the BIM Exchange, and it has the ability to execute different services provided by the vendors. For an example, let's take a scenario. An IFC file contains maybe from the plumbing team, it has machinery information along with the supplier's information and the cost information, but this is not actually shared to the different parties. So the plumbing team, when they checked in IFC file, it could actually execute a service that returns you an Excel file which contains all the machinery with their cost information. So with a single API call, all the other teams are now able to download all the plumbing related machinery data with an API call. BIM Exchange is a very secure platform. It could be configured based on different security standards, and it could limit information based on the teams and their permissions, so that only the allowed teams has the access to the API, which is completely governed and controlled by BIM Exchange. So this actually addressed one of the points Derek mentioned in terms of the security. BIM Exchange also comes with a user interface that actually consists with project information. It has the power of 3D model visualization and analytical dashboards as well. A large BIM project in a BIM Exchange could be divided into so many sub-projects for different teams, and they all work in their IFC model in isolation. In the central management interface of BIM Exchange, it could visualize each of these 3D models. So the cool thing about this is consolidated 3D views could bring a lot of value to it. For an example, by combining architecture teams and plumbing teams IFC files come together, it could actually produce a 3D view of the building, not only the structural view, but you can actually see in the structural view how the plumbing is going through the roof or going through the floor in one complete 3D model. So analytics also introduce a great deal to the BIM Exchange platform. Let's say when an IFC file is checked in, there are so many information inside it, like different elements represent different data. So it could actually identify certain elements in the file and perform instant analysis on it. So we actually leverage on WSO2's complex event processor, and it gives us a great advantage of processing this kind of tedious task. So it could actually instantaneously analyze model data values and execute certain business rules and alert the users then and there if there's a problem. A great use case is there's a common use case on collision detection when it comes to BIM. For an example, like two structural teams working on a particular scenario, and they are building two walls actually colliding with each other. So when they actually submit their IFC files, it could actually analyze this collision and immediately warn the user, saying that hello, there is a collision going to take place. So these are like real world use cases that probably add a lot of value. Since BIM Exchange built on top of WSO2 middleware platform, it gives a great ability to integrate different information sources that are not in the BIM context, but yet important to a construction project. So this means BIM Exchange is not only a platform for BIM-related data exchange in a construction project, but also it's viable for performing any related data integration. Another great advantage is that BIM Exchange, it could be deployed on-premise as well as on the cloud. So therefore, essentially, BIM Exchange is cloud ready. So that's as a high level about BIM Exchange and how it's basically work. So if we move on to the next slide, I just talk about industry foundation classes. So just to give a brief about it. IFC, as known as Industry Foundation Classes, it was formed in 1994 by Autodesk with the help of 12 different companies. And initially, it was developed as a set of C++ classes to manage interoperability between different applications. And it got evolved, and 1997 it had a different name, International Alliance of Interoperability. And after that, in 2005, of course, it got the name IFC. And after that, it was evolving from different versions, and initially we had 1.5, and the latest which was released in 2014 as IFC 4 standard. But the model is continuously elaborating, and we saw last month there had been a new release, certain model development for the latest version, which was released last month. So IFC actually comes with different set of file formats. We have the file base, which is the flat file base, step file base format, starts with .ifc. And also we have a XML document, which is IFC XML, and also ifc.zip, which is actually the zipped version of the XML file. So these are the output files which could generate from different BIM-enabled applications such as Autodesk Revit and ArchiCAD, and there are many other famous, different CAD applications that could generate IFC information files. So if you actually look into the IFC file, it is something similar to this. It actually represents a data model. We have different elements represented in the file. Essentially, when it comes to a building, you have IFC building, IFC person, and so many definitions around it. And everything is uniquely represented by a particular line. And to represent the relationship between these elements, this line is repeated or referred in a particular line that is used. So the documentation for IFC is available on the below link that I have mentioned below. We can have a look at it in detail if you go to the standards. So let's look into the high-level architecture of BIM Exchange. So what we have done is there are several different use cases. Basically, applications who are BIM compatible and non-BIM compatible applications could integrate to the BIM Exchange using the BIM Exchange API. And we have BIM Exchange users. Essentially, these are the architects, the engineers, the project managers, the project owners, the risk managers, and everybody connecting to the BIM Exchange using the BIM Exchange user portal. At the same time, we have the BIM Exchange administrators connecting to the BIM Exchange using the admin console. So applications and BIM Exchange users could be using the application by submitting IFC files. For BIM Exchange users, they could be manually submitting an IFC file by just like a file upload, or else an application is automated using the API to automatically submit the IFC files to the BIM Exchange. And once the file is submitted, it will be processed and the business rules are executed. So we essentially use BIM Server, which is an open source standard, which has a lot of functionalities in terms of BIM. And we have, of course, extended this functionality with our own set of functionalities, which adds a lot of value. But in order for you to actually manage this whole process as the engine, we use the complete WSO2 platform, because we wanted to make sure the file which is submitted is managed in such a way where efficiently and extendability aspects comes into play, and we have a better result. So once the file is submitted, it is actually governed by the API manager of WSO2. Whatever the API that we expose from our BIM server is wrapped around with the WSO2 API manager, and it is governed by the WSO2 identity server for the security aspects. And whatever the file submitted, it will be taken inside from the WSO2 API manager, will be managed to the message broker, and we have the enterprise service bus actually managing the integration and also performing analysis. We have complex events processor as well as business activity monitor. So this will be explained in the next session conducted by Dasana. So I'm just giving you an overview of how the BIM high-level architecture works. We also have the user engagement server used to perform the front-end applications such as BIM Exchange user portal and BIM Exchange admin console. So why WSO2 middleware as our base platform? So we had several key reasons to choose WSO2 as our base platform. BIM Exchange ideally exposes an API. So we needed a highly sophisticated API management facility to give this API out. So we knew that API Manager introduces a great capability of different QoS factors like throttling and security, and give us a great flexibility of managing the API. So we actually use the API Manager for that. At the same time, we needed top-notch security because we know the BIM, when it comes to BIM, it's utmost necessity that we have very, very high security. So we knew that Identity Server could deliver the exact same thing. So we wanted to use Identity Server of WSO2 to security platform. And we need a very, very high capable integration platform because this BIM Exchange is all about integration because we have so many files sent to the system and integrations are taking place between different applications and also legacy applications connected to the system. So integration is a key. So we knew the power of ESB and what it could do, and we knew that's the only thing that we could have to achieve such kind of tedious operation. And we knew we needed to have advanced dashboarding analytic capabilities, and we knew that complex event processor could actually give us the exact thing that we need in terms of analyzing instantaneously and provide alerts and all that things, because a lot of calculations and decision making has to be taken place when an IFC file is submitted, because an IFC file could be very large, containing thousands and thousands of elements. So we knew CEP actually gives us this advantage. As overall, we have a very lightweight, reliable, extendable, robust platform as WSO2 to be used with BIM Exchange, and we were pretty sure that it could actually give us the best results possible. So in order to explain the inner workings in terms of WSO2 components inside the BIM Exchange, I just hand over this session to Dasana to take over from here. Thank you.
Hi everyone, thanks Dwaraka. So let's dissect the high-level architecture presented by Sudharaka in his session into different components, and let's look at how WSO2 middleware components come together and make this BIM Exchange platform. So if you look at the component set is the BMI Exchange APIs 2. BMI Exchange APIs 2 provides the secure API gateway, which is the entry point to the building information modeling capabilities provided by the BIM Exchange platform. It creates the API facade integration pattern, and it supports B2B and B2C integrations through WSO2 API Manager and WSO2 Enterprise Services Bus. There are three components come together to form the BIM Exchange APIs 2. Those are WSO2 API Manager, which basically provides the API management capabilities, and WSO2 Enterprise Services Bus, which provides the integration capability for legacy applications, non-BIM standard components, and other integration that might be relevant for the engagement. So it provides the service mediation capability. And behind the scene, WSO2 Identity Server provides authentication and authorization services for WSO2 API Manager and WSO2 Enterprise Services Bus for establishing security. And internally, we use a persistence tool, and it will be used for storing the identity information which consume APIs from the platform. And WSO2 Enterprise Service Bus will directly integrate with BIM engine, which exposes services to the outside world, and it will have two paths. It will run through API Manager, or it will directly integrate with B2B integrations through WSO2 Enterprise Services Bus. And the beauty of it is like we have this WSO2 Enterprise Services bus, which provides a declarative model for quickly coming up with B2B integrations. So it's very much capable of handling non-standard BIM integration that we need to support in different projects. So let's deep dive into the components of the BIM Exchange API store. The BIM Exchange API store is kind of modeled as an API marketplace or a store where APIs, documentation, how-tos, samples, and issue management system entry points are made available for users. User needs to subscribe for the API to use, and subscription process is well defined. An organization could extend subscription flows by customizing the API subscription flows, and different departments could have different subscription models. So this provides a way of collaborating teams and different levels of security against each collaboration model. An API manager provides sandboxes for testing, and push to production process is made available for subscribed users. API store provides tools to test and analyze different components of the APIs. And APIs are secured using OAuth2 standard and support all grant types. And it may extend itself to support any other standard security mechanisms, and there is extension points that we could extend the platform to support non-standard security platforms that we need to be integrated with. API store is multi-tenant, and each organization which is modeled as a tenant will have its own store, and it can have their own themes. So the multi-tenancy is very important because we need to isolate this sensitive data between projects, between different teams, and likewise. And APIs are bound with QoS and SLAs. API analytics are provided by collaborating with another middleware component called WSO2 Business Activity Monitor. And so let's look at how the API analytics are performed using business activity monitoring. The WSO2 API Manage component generates events on API usage and feed those events into the WSO Business Activity Monitoring component. The events may come from ESB as well, because it will perform legacy integrations as well. So this event data profile is very rich. It contains a lot of information. So data publishers deployed on both API Manager component and the ESB will push these events through Thrift, which is a very powerful protocol to be sent, like when the events are sent, and these events will be consumed by business activity monitoring tool. A WSO2 BIM component store these events on a scalable cluster of Cassandra nodes and use a Hadoop cluster to run MapReduce jobs to summarize the raw event information. So this setup provides a very scalable and fault-tolerant platform to analyze these events, which is kind of necessary because we are handling a lot of large amounts of data. So it is very important that we handle it in a very performant way. The business activity monitor handles the cross-cutting concern of business analytics, and it will be consumed by other components of the platform. It's a cross-cutting concern basically. The BIM will host several analytical toolboxes, and related toolbox will kick in for the respective event stream. These the different analytical models are having a kind of a declarative programming model, so you can easily modify them and they can be deployed runtime. The processed information is consumed by different consumers like business analytics dashboard, administration consoles, and other platform dashboards. What happens is business activity monitoring component will analyze this data and it will push this analyze or summarize data into our BIMaaS database. So it will be kind of shared among the platform components to consume that kind of summarize, analyze data to be kind of put onto dashboards. That's where the business activity monitor comes into play to perform the business analytics. Now the entire building information model is the different functionality that we provide on business information model is asynchronous because we are handling a lot of large data sets and it cannot be done synchronously. So we are having a asynchronous model in handling these IOSC files and other information. So the BIM Exchange perform IFC file validation and merge operations in asynchronously using the WSO2 message broker. WSO2 message broker provides a persistent message store and message queuing capability, which is highly scalable and fault tolerant. It's based on Cassandra, which is NoSQL, highly scalable database. And WSO2 message broker closely cooperate with WSO ESB in order to establish this persistent message store. The messages or IFC files and metadata is stored on a NoSQL storage, and BIM engine services are subscribed to the message store. The services will be notified and each job will be picked up from the message store, and processing will happen in parallel in a distributed manner. The message store audit services will provide useful information to the operational dashboard real time. So it provides a kind of insight into what's happening on the BIM engine and how the different IFC files are processed and how the model is kind of formed based on this IFC file information. And now let's look at how the real-time analytics are established on BIM platform. The real-time analytics are used when handling IFC files, basically when merging different layers of building information into the common model. The various components of the BIM Exchange platform will generate different events real-time and feeds those events into the WSO2 complex event processor. And again, like on the business activity monitoring, WSO2 complex event processor will be using Apache Thrift and a reliable and fast API to consume those events. Complex event processor uses high performance, low latency Thrift API to feed these events, and it hosts a set of real-time analytical models which can be fit onto these event streams. So what happens is these analytical models will kick in once the stream is filled with events. And each analytical model is implemented using a SQL-like query language, which is runtime deployable. And there will be multiple models with different privileges, different security models attached to each model, and will be deployed on WSO2 complex event processor. The resulting events, these event processing is happen on the run, like on the runtime in memory, and there will be events generated out of these analysis, and these events will be consumed by different components of the platform, and they will be consumed by different dashboards as well. Now let's look at how different services are being exposed on the building information model. Now the building information model is dataset, and we wanted to expose different services, basically the CRUD operations against this building information model, because different parties will correlate and they will contribute different information into this centralized model, and that model has to be updated and kind of validated, and the data will be grown. So what we have done is we have introduced WSO2 data services server, and data services service server will be sit in front of the persistent model or the persistent store, and it will expose the CRUD operations as web services on top of the persistent store. And each services or each set of services will be defined and configured using a declarative programming model, and it is based on XML, and the DSL is XML. So the services can be easily modified runtime for change management. So we can easily modify them on the runtime, and there's no need of server reads in a production deployment. And these large files will be used, and it will be used on a streaming, and we can handle large data volumes easily. The services are enabled, and there will be set of performance improvements that we can perform on the data services service, like caching and other stuff, for better performance. And these services will be consumed by BIM engine, and BIM engine houses a business logic, and it will be depending on data services server exposed services API internally for performing different building information model business processes. And we use another two components here. One is business role server, another one is user engagement server. User engagement server is used to model different dashboards. It's a UI set of UI components are used for modeling this different graphical representation of the business building information model. And business role server is used to keep different business logic in roles, externalized into roles, and BRS is used as a component inside the platform to manage these roles. So basically, these are the high-level components that are being used from the WSO2 middleware component in order to achieve the functional goals of BIM API, BIM Building Information Modeling Platform. So this brings to the end of the WSO2 middleware component, how the WSO2 middleware components are being used inside the BIM platform. And I think we can go for the QA session if the participants have any questions.
I think there is a question.
Yeah. So the question is whether we could see some screenshots of the dashboard. This is under development, so we haven't kind of made ready any dashboard screenshots for you. There will be kind of three types of information that we are planning to kind of host on the dashboard. One is real-time information that will be kind of updated real-time. The second type of information that we make available on the dashboard is the three-dimensional project modeling. And the third type of information is the historical analysis that is performed on the data, the business analytical information that is available. So those are the three types of information that we are planning for to be kind of exposed to these dashboards. And these dashboards will be kind of Web 2.0 standard and will be kind of very responsive UIs. Okay, so the next question is what is the release date? The release date is the beta will be out by end of June, and there will be subsequent releases until GA. Currently, what we have done is like we have started with 3 highly skilled developers in the team as the core developer group, but we will be kind of expanding into kind of expanding the team because we want to kind of expedite the work that we are planning to put on as features on the first release. The next question is what are the kind of pricing information or the pricing model that we want to follow on this BIM Exchange. So since we are using open source, the WSO components that are being used on the platform is open source and uses the Apache 2 licenses. So probably we will go in line with that, like make it the platform is open source, and probably we'll charge based on the usage, like the enterprise support will be charged, something like that. But we haven't kind of concretely defined the kind of pricing model. We are currently working on that, but it's leaning towards open source models that is available.